Next, let's look at example 12. When we calculate continuous decay, okay, the word continuous means you have to use the formula with the E in it. That is the one that says AT equal to AERT. Now the continuous the decay rate is 17.3% per day. So we need to know 100 milligrams of the stuff decay in 3 days. So first, let's write down the formula. Okay, it says continuous decay, so we need to copy down the proper formula, which is the one with the E in it. And so A of t equals to AERT. Now the E stands for a number, 2.718 or something, okay, whereas all the others are variables depending on your situation. Now in this case, the decay rate is 17.3%, all right, so which is the same as, we'll write it as percentage negative, being that it's decay, don't forget to put a negative sign in there, negative 0.173, like this, okay? And then the time is how many days? 3 days times 3. And then A is 100 milligrams. That's what we are starting with. All right, so there is our formula completed. This is the initial amount, that's the time, and that's the growth or decay rate. If it's decay, then it has to be negative. If it's growth, it's positive. Now that we know all that, please type it into your calculator, as I will do, and then we'll see what the answer is. So I have it typed into the calculator, okay? As you can see, 100, on my calculator to type in E, we have to push the shift button right here and then push the natural log button, which is right about here, this thing, okay? When on top of there, then you can see the E button. Let's see, is this gonna zoom in? And well, anyway, so that should be how that works. Now, once you get that in, maybe I should stand over here a little bit. Okay, and well, in any case, so that should be should be typed in incorrectly. So I got the answer is 59.51, which is that what it says? Yep, that is correct. So that is the answer to that problem. And that's example 12, which we have come to the end of the section. For homework, please do all the examples except 7. You don't have to do 7. And do them in such a way that you just look at the problem like they're homework without looking at the explanation or the answer. See if you can get the right answer yourself. And then that way, if you have any trouble, you can refer to the explanation to help you understand it better. And so after that, please do the homework problems. Problem number 11, 21, 23, 26, 31, 45, 47, 49, 51, 61, 63, and 65. And when you're done, I want to talk about some of them. Now that you're done with homework, let's talk about problem 23. Now, problem 23, we need to figure out if this is a linear growth or a linear expression or an exponential function. And so let's to tell that, you just look at the difference between the values of f of x. Now, when x is 1, f of x is 70. When x is 2, f of x is down to 40. The difference is 30. Okay, remember that? 30. And then and at 3, when x is 3, f of x is down to 10. The difference from 40 is still 30. So it's going down by 30. Okay, at 4 is negative 20, again down by 40. So that's called a linear situation, and it is not exponential. So that's the answer, is that this thing is linear. Okay, and so next, let's look at problem 26. Now, problem 26, as you can see, we do the same trick. Where the problem goes from at 1 is at 10, at 2 is at 20, so the increase is 10, okay? And then at 3, it went up to 40, so the increase is 20. So the difference start out at 10, but now it becomes 20, so the difference is increasing. And then at 4, it got to 80, so it's really growing fast. As a result, this is an exponential function. Now, we also need to find the function that passed through these points. So let's do that for problem 26. Now first we need to know the formula for the exponential function. The formula normally is, let's call it P, okay? We'll call it P equals to A times B to the power x. That's your general formula for the exponential function. We are going to put in the value of x. Why did I say P? You should say f of x, because that's what we have right here, okay? The y value is called f of x. So let's write that down as f of x, okay? And then a and b, we just need to figure out what a and b is in this particular problem for problem 26. So let's plug in some numbers. First, let's choose x equal to a, okay? If x equal to x equal to 1, the easiest option we have. When x is 1, fx equal to 10, so 10 equals to a times b. That's our first clue as to what a, b are. We don't know what they are yet, but we know they multiply to be 10. Okay, that's a clue. And next, let's choose x equal to 2. If x equal to 2, and then it becomes, plug x in here, it becomes ab squared, okay? And that becomes 20. All right, so these two situations should be enough for us to figure out what a and b are. The way we're going to do it is we're going to plug a out of here and then put it in here, okay? From here, we get a equal to, I'll write it over here. So then a equal to isolate a by pushing b across the equal sign down to the bottom, okay? So then a equal to 10 over b, right? And I just took the b and pushed it down here. And so a is 10 over b, and then we'll put it in here to see what happens. Then we get 20 equals to 10 over b, that's a, times b squared, which is equal to, cancel out some 1b, that's 10b. So 10b equals to 20, so b equals to 2. So b equal to 2, and then a times b is 10, so which means a is equal to 5, and that should be our answer. So the function we're looking for is 5 times 2 to the power x. And that should be the answer to this problem. And we can check this. There's no answer at the back of the book because this is an even problem, but we can still check it, okay? Then when x is 1, then this is 10, right? 2 to the first power 1 times 5, that's 10. So far, so good. And then when x is 2, that becomes 4 times 5 is 20. That says 20. When x is 3, 2 to the third power is 8. 8 times 5 is 40, says 40 here. And finally, when x is 4, 2 to the fourth power is the same as 2 to the second power times 2 to the second power, which is 4 times 4, which is 16. 16 times 5 is 80. Which is what is given here. So this should be the right answer for problem 26. Okay, so next let's look at problem, I want to talk about 61. So flip over a few pages until you find problem 61, and where we talks about the fox population. Now for problem 61, please consider example 3, okay, in this section. Example 3, because it's the very similar problem that talk about the population. So whenever you see a problem, and all you need to do is find an example that does a similar thing, and then just copy the same trick. And so this is so please see example 3 if you had trouble with this thing. The fox population has a growth rate of 9% per year. Okay, so the formula is still this thing right here, and this time we're going to write down P for population equals to A is the initial value and B is the growth rate, and that is the population formula in general, and X is the time, whatever. So then the B, the growth rate is 9%. Now in this type of problem, what you do is you write down B equals to 1 plus the growth rate, which is 0.09, okay? That stands for 9%. 9% is 0.09. So that would be our B, okay? And then that's the growth rate. And then A stands for the initial amount. In the year 2012, there were 23,900 fox. So let's write that down. 23,900 foxes. And then counted And so its growth rate is 1.09. Okay, that's for B. And then we'll raise it to how many years? And what do we want? We need the fox population in the year 2020. Well, we started at 2012, so that means x equal to 8. We're talking about 8 years later. So we'll change x to 8. All right, and that gives us the formula to calculate the population of the foxes at the year 2020. So let's put that into the calculator. Okay, I typed it into my calculator. As you can see, there is 23,900. Okay, so far so good. And times 1.09 raised to the power 8. Okay, my calculator had this button right here, x something, and that's the exponent function. And your calculator should have something similar. And sometimes they have different symbols, but they mean the same thing. But anyway, you type all that in, and that should be okay. So I got 47,622 foxes. That is problem 61. Let me check the answer here, and it is correct. Okay, so that is that's that. Now, for some reason, your book says the word fox. I don't know why. It shouldn't be foxes. But anyway, this is not an English class, so we don't really care. And so let's look at next problem, problem 63. There's a similar kind of problem. Okay, the value of the annual growth, the value. Okay, so. Problem 63, we have the house situation. Now, let me write that down. Now, the house is valued at 110% to start with. This is the same formula we're going to use, okay? So we'll just use that one. The house is valued at 110,000, so let's call it 110, okay? Remembering that we're talking about thousands here. And then eventually it became 145,000. What is the growth rate? When did it become 125,000? 45,000 in 20 years. All right. So the time is 20 years. So there's B. Okay, and then it eventually raised to 20. So the questions, what is B? That is, what is the growth rate? The B will be equal to 1 point something, and then we'll subtract 1, and that will give us the growth rate. All right, so let's do that. Now to solve for B, we are going to first push the 110 down here. We need to isolate B. Okay, so get rid of everything around it. So this becomes 145 divided by 110. And then that's b to the power 20. And then how do we get rid of 20th? We're going to take, that's raised to the 20th power, so we're going to do the opposite thing and take the 20th root of all. So raised to the power 20th root on both sides. Okay, 1 over 20. So this is just b, and we'll use the calculator to figure out what this is. So let's punch this in. So I type this into my calculator. Don't forget the parentheses, very important. Okay, so we have 145 divided by 110 raised to the power 1 divided by 20. The 1 divided by 20 probably doesn't need parentheses in my calculator, but if you want to play it safe, you should add it anyway. Yeah, so that's that. And so once that's done, that should give us a value of b that's 1 point something. Yep, the answer is 1.0139. Okay, so let's write that down. And specifically, B is 1.0139, and the rate is then the point is right here. All right, so the rate is 1.39% of growth, okay, if you change it into a percentage. So the rate is this number minus 1, because the rate is always, B has something to do with 1 plus whatever rate that your growth is. And so that should be the growth rate. Now, so the next question, but this problem has a second part. The second part wants to know what is the value of the house in the year 2010, which is 5 years later, or 25 years from the year 2020 to 1985, right? So this number increases to 25, and we can plug that in with the rate being this. So B now equals to this value, so let's plug that in. Okay, so it's 110. Okay, B is now 1.0 something, 1.0139. 139 raised to the power 2010 from 1985. That's 25 years. And yeah, that's about it. So let's type that in and see what happens. So I have typed in here. All right, that is 110 times 1.0139. That's raised to the power 25, so that should be correct. And our answer is 155.335. So that is that would be the answer of the well. So it basically is 155 and then and 3,000. Okay, well, and we have that's good enough. Okay, and it doesn't need to be. The book gave the estimation of the house is 100-some thousand down to the cent. It's not that's not necessary. We just four significant figures is good enough for anybody. Okay, so the house will become 155 as the answer shows. So that's problem 63. And finally, I want to talk about problem. What is the last one? 65. Okay, somebody who wants to save money for the down payment of some home. Okay, how much does he have to invest? Now, first we need to remember which problem, which example or which formula we're supposed to follow for this problem, and then the specific formula is that thing right here. The investment formula, okay? The compounded daily, all right? So this thing is compounded daily, so that matters. And where's the formula? The formula equals to the total amount, I think. The total amount equals to the principal times 1 plus, let's see, R over N, okay, times the power NT. I believe that is the formula. Let me look it up for you. Yeah, right here. See, I got it exactly right. That is okay. That's the compound. That is the compound interest formula, and this is on page 552. Okay. And that is right before example 8. So for this problem, please consult example 8 if you have any trouble remembering how to do it or anything like that. So see example 8. Example 8, okay, consult example 8. Now but anyway, so we're going to do this problem. Let's all right, so let's do problem. I wrote that wrong. All right, problem 65. What we need to achieve, okay, guy wants to save $54,000. All right, so that's the total amount he's driving for is, what was it? 54,000. Okay, 54,000. I'll just write down 54. But remember, that's 1,000. And then how much will he need to invest in an account with 8.2% interest rate? So the R is 8.2%, which is, and we'll follow this formula, okay? And we don't know what P is, I guess. What do we know? We'll worry about that later. 1 plus 8.2, which is 8.2% translates into number is 0.082. Okay, and then right here, I'm following this formula. And then compounded daily. That means it's compounded 365 days, right? And we'll take that as 365 days. And then he will, and then continue, and then he will, the time is 5 years. So we'll raise it like this, 365 times 5. Okay, because he's compounding daily. Okay, so that's pretty good. And what are we looking for? We are looking for the principal. That is how much. Yeah, I think so. It says how much will he need to invest. So what is his principal for all this to happen? All right, so the principal then equal to, so P equals to the 54 divided by that whole works, okay? And I'm not going to write it down here, but there is everything here, okay? Raised to 365 times 5, everything. Just take that whole chunk and imagine it's sitting down here instead. And take 50, divide by all that, and then we got the answer. So please type that into the calculator, and then I will do the same. Actually, I think I will write it down to make it clearer. What I'm going to do is I'm going to put in extra parentheses. So I'll write down all that thing inside the big parentheses, okay? So let's see, yeah. 1 plus 0.082 divided by 365, okay? And then times 365 times 5, like that. So, and I'm typing it in exactly like that. The reason is because there is a division situation here, and I probably don't need the extra parentheses, but I'm adding it just to be safe, and I encourage you to do so. But you have to keep track. You got 2 parentheses, so you need to end up with two. When you have 2 open ones, you better end up with 2 closed ones as well to keep track of all the parentheses, and that way we know that everything is coming out properly. So let me show you what I typed in, okay? I have 50 divided by 2 parentheses, okay? And then the first one is 1 plus 0.8, 1 plus what? 82 divided by 365. The calculator does know how to do division before addition, so you don't need this in parentheses in any scientific calculator. Okay, and then continuing, and we have stuff on top, right? 365 times 5, okay? And then maybe I should stand some, whatever. And then, what am I doing? Oh, it went all the way to the front again. And then raised to the power 365 times 5. Where's my close parentheses? I think I forgot to put it. Yeah, there's one more. So I have 2 close parentheses. That's not counting the stuff that's on top, which I also put in parentheses. That's just to be safe. I don't think I need it here because everything's on top. So I think the calculator knows. But I just did it to be safe. And anyway, so that should do it. And let's push the equal button, which is right here. All right. And we get 33. Okay, 0.184. So the principal that the guy should invest would be 33,000 equals to 33,000, and then $184. Let's make it complete, and that should be the right answer. No, the book has a different answer. Why is that? It's similar. They said 35. Let me check to see if I messed up. Okay, I found a mistake right away. It says 54, right? Why do I have 50 here? What happened to my 4? Wrong. So let me fix this stuff. Okay, erase that. Okay, it's actually 54. Excuse me. Get rid of that. Okay, so I'll fix it in my calculator. Change it to 4. Okay, now it's 4. Let's try again. Push the equal sign. We have 35,839. Okay, so this time I got 35,839. Is that right? Yes, it's correct. Yay! So that's much better. And that should mark the end of this section. Now, it's been a while since I've recommended any books. I just haven't thought about it. Well, I thought about it between videos, but I always forget when I'm doing my video. So I want to recommend a book to read that has nothing to do with math or algebra. It's just a book I like to read, and I think math students should do some reading. That's awesome. The one I want to recommend today is called Bone, okay? And it is... It's a graphics novel, and it's fantastic. It's by Jeff Smith. I will also write the recommendation in the under the video. Okay, as you can see, look how beautiful the artwork is. So anyway, it's a fantastic graphics novel series that I found by accident, and there's like several books, so 7, 8 of them or something, and so please read that if you can. It's not going to help you algebra necessarily, but it's tremendously fun.